Thanks for coming in out of the beautiful sunny day here at talk. It's air conditioned in here. My name is Arnie Miller. By trade, I'm a paleontologist. Do you know what that is? What is a paleontologist? Paleontologist is somebody who studies fossils, and so most people who think about paleontologists think about dinosaurs, because that's what a lot of paleontologists collect, dinosaurs. But I'm not one of them. I actually am interested in the fossils, the skeletons, shells of critters that either live or lived on the seafloor. And have any of you ever seen the rocks around Cincinnati before? Have you taken a look at the rocks at all? How many have seen them and know that there are fossils in them? Yeah. Okay. And so that's good. What I want to do today is I just kind of want to tell you a little bit about how these rocks got here and why they are the way they are. And interestingly enough, and this is where the extreme weather comes in, and it might surprise you to know that at the time when those, well, you probably know that at the time when those rocks were deposited, because they have the shells of sea-dwelling animals in them, it tells you that this area was covered by a shallow sea. What you might not know is that this area was also extremely hurricane-prone. And at that time, that time was about 450 million years ago. And so what I want to do today is sort of talk about a few different things that, if you combine them, help you understand what it is you're seeing in the rocks around here and why. And so I'm going to begin by talking about storms and hurricanes, and I'm going to talk a little bit about how life has changed since the Ordovician compared to the present day. If you were to go scuba diving on a seafloor today, or just walk on a beach and pick up shells, and if on the other hand you went into a time machine and did the same thing in the Ordovician, the shells that you would pick up would be rather different, and those are the ones that we see in the rocks around Cincinnati. And so I want to talk a little bit about that. The other thing, the Earth is a very restless place, and you've heard even recently about major volcanic eruptions and earthquakes and things like that. It's all a reflection of a process that's called plate tectonics. What that means is that there are these sort of superficial or superficial plates on the Earth, and they move around, and the continents move around with them. And this is a sort of a shorthand way of saying that Cincinnati was once in a very different place than it is now, and I'll try to map that out for you. And then finally, the other thing is, and you hear a lot about global climate change in the present day, it turns out that and you also know that, you probably heard something about past ice ages and things like that. Well, in the past, and probably through the future of the Earth as well, we get changes in climate. And this leads to times when the Earth is warmer and when the Earth is cooler. And when the Earth is cooler, ice areas, glaciers and other areas that are covered by ice, grow, and so sea level goes down, and the opposite happens when the Earth warms up, and we see that reflected in the rocks around here. So you throw that all together, and you have the Cincinnati. Okay, so the first thing I want to do is talk about hurricanes, and there's one that I'm going to focus on because I happen to have experienced it, but I'll make some general comments about hurricanes. So first, a little bit of just a hurricane primer. These are a couple of images, a radar image of a hurricane known as Hurricane Hugo, and a satellite image of the same hurricane as it was approaching the South Carolina coast. This was way back when, in 1989, so quite a long time ago, actually, approximately 29 years ago. Anyway, as it turns out, I was working down on the island of St. Croix in the Virgin Islands when Hurricane Hugo did a direct hit at St. Croix. And it actually turned out to be, from a scientific standpoint, good fortune for me, but bad fortune otherwise, and it was not a wonderful experience. After that, it hit Charleston, South Carolina, but that was a little bit later. But before talking a little bit more about Hugo and its aftermath, I wanted to talk about hurricanes in general. Anybody know what fuels a hurricane, basically? What does a hurricane need? Yeah. Warm water. Okay, warm water is key for a hurricane. And it's basically like a big heat pump. So this is sort of a hurricane in cross-section. And what you saw in the middle was that, if the other images was the eye, and you hear about the eye of the hurricane being calm. Right around the eye, which is here, is what is called an eye wall, and the winds are at their strongest right around the eye wall. And we don't have enough time to really go into the details of the structure of hurricanes, and it would probably bore you in any case, but just sort of understand that these big, really, heat convection pumps, really, and what really fuels them is warm water. And what that means then is they tend to occur at certain times of year in certain places. Because water is warmest in the tropics, hurricanes tend to at least originate in the tropics, and then they'll move away from the tropics. And if you pay attention to the worldwide weather as I do, and I'm kind of like a hurricane fanatic now, what you find out is that they have these other names for storms, depending upon where you are in the world, but they're all the same thing. So if you're in the Western Pacific, they're called typhoons. If you're in the Southern Hemisphere, for the most part, they're called cyclones. And if you're in the Atlantic Ocean, which is where we are here, and also the Eastern Pacific, so surrounding the United States, basically, they're called hurricanes. But hurricanes, typhoons, and cyclones are all the same thing. And you can also see that they tend to move from east to west. Again, this is something that would take a little time to explain. If you're in the northern hemisphere, they tend to bend to the right, they tend to bend to the left in the southern hemisphere. The point is, though, they form over warm water. And what that means is that they tend to form in the northern hemisphere when the water is warmest. And so we're actually now going to peak hurricane season because it's sort of late in the summer when the water in the tropics is at its warmest. And this has been kind of a quiet year so far. As you may recall, last summer was not so quiet. And this is a map from 2005, which was the year of Hurricane Katrina that some of you may remember, and some of you don't, but some of you do. And that was a very busy year. In fact, it was so busy that, and as you know, as many of you know, they named hurricanes after people, basically first names. And they got all the way through the alphabet that year, and they have to go back to like Hurricane Alpha, as I think they call it. Anyway, there's just a whole bunch of them, and you can see that some of them have funny little patterns. You really can't, perfectly predict sometimes where hurricanes will go and how they'll intensify. But you can see, actually, and here's Cincinnati right here. You can see a few of them, and this is the deeper the color, the stronger they were. Some of them maintain tropical storm status all the way up to the Cincinnati area back here, which is kind of a weak, just a grade below hurricane, but still a good windstorm. And as you probably know, sometimes it rains coming around here. But here is what I think is a really cool map. And this shows the pathways of hurricanes pretty much on the same footprint as this. But for more than actually about a century and a half. So from 1851 to 2004. And what you can see here, and this is the important point that I want to make. If you're in the tropics and in tropical waters, in the course of a century and a half, it's almost inevitable that you'll be hit by a hurricane, probably multiple times. And so you can see that it's just sort of black ink here, because when you add all these together over a century and a half, it's just a ton of storms, basically. And that's important to keep in mind for what we're going to see in just a moment. Okay, so a little bit about Hurricane Hugo and me. So as I mentioned, I was here's St. Croix. In this inset map, that's Florida. This is Cuba. This is Hispaniola, Haiti, the Dominican Republic, Puerto Rico. St. Croix is over here. And so here it is now there. And as I mentioned, in 1989, I was there. And so this is a map showing really sort of the life of Hurricane Hugo, which was in September of 1989. It started off the Africa coast. These are the Cape Verde Islands, and if you pay attention to hurricanes, as I do, you'll often hear the term Cape Verde hurricane, because especially around this time of year, actually, as we go into late August, the Cape Verde season begins. And so hurricanes sort of originate basically off the Africa coast at this time of year, although they can originate other places as well. So it traveled across the Atlantic Ocean, and as it deepened, when it got to here, it was at its strongest. Weakened a little bit as it came into the Caribbean. St. Croix is right about here. You can see it's orange, so one down from red. We don't have enough time to go through the details of what these numbers mean, but I'll simply point out that when Hurricane Hugo passed over St. Croix, it had sustained winds of about 160 miles an hour, and it was moving very, very slowly. And so I remember, this is sort of again showing, this is something I just read myself. That's the island right there. This area and had sort of the eye of the hurricane, which it turns out was kind of elliptical rather than round when it was passing over St. Croix. And you can see from the pathways here at different times. This was 5 the next morning. This is about 11 o'clock, 1 o'clock in the morning, and so forth. It took this very tiny island, it's only 21 miles long. It took several hours to go over the island. And you can also see that the eye of the hurricane passed over the west end of St. Croix. I was on the east end of St. Croix during the hurricane. I was at the West Indies Lab. So I was under what's called, these donuts are sort of, not conveying this, the hurricane was much, much bigger than this, but this is the eye wall. And that's where the winds were the strongest. We were basically standing or hunkered down under the eye wall for quite a while. And so just some pictures. This is the east end of St. Croix, which if you're into trivia and you don't count Guam, which is on the other side of the international date line, this east point is the easternmost point in the United States. It's St. Croix is the U.S. Virgin Island. That's on a calm day. Oops. This is in the afternoon before the hurricane really began to hit, and it's just kind of picking up a little bit. Very quickly going to just click through these. This is I was staying at a place called the West Indies Lab. This was a yacht club, which was across the street. And this is just when things were starting to pick up, getting up to sort of tropical storm force strength before the hurricane really hit. When it was really hitting, we were in a room that the roof was starting to come off of. Anyway, this boat went down pretty early. I could say something about that. I won't right now. This is taken around the same time, showing many boats that were in the harbor at the St. Croix Yacht Club, including, notice, for those of you who are boating enthusiasts, this is a trimaran, so a multi-hull boat. Oops, sorry, going too fast. I want to show you just a few before and after pictures from this particular storm that we took. So this complex down here in the valley was the West Indies Laboratory, which was a really nice place to live and do research for many years. And this is what it looked like the day after the hurricane. So several buildings had lost their roofs. This is the thing that impressed me the most. This thing right here is a Coke machine. So somehow that Coke machine during the hurricane got lifted and had been over here. Got lifted and moved over here. But we're still upright, go figure. You know, and there are also other little things like that. Rebar stakes through tires and kind of things like that. This is a lab building that one of my colleagues was doing work, and you can see we were boarding up the building the day before the hurricane. It really didn't do much good. This is the harbor that we saw a moment ago that had boats in it the afternoon before. So where are the boats? Well, one of them is kind of down here. Most of the boats, though, are just up on the shore, washed up there. What you don't see, for the most part, are the multi-hull boats, the catamarans and the trimarans. It turns out that the same thing that makes those boats faster, namely that, among other things, they're lighter. The fact that they're light also gets them carried by hurricanes. They're pushed, and so the multi-hull boats are like back here somewhere. This is another area that I was working on in St. Croix. I was actually there to do some work in a habitat living underwater. And we were supposed to be underwater when the hurricane hit. And so spending a week on the seafloor, basically. And so we agreed, along with the people who were running this operation, the National Geographic and Atmospheric Administration, that we wait till after the hurricane and then in the war. As it turned out, there really was not much of an after. So this was like the land base of that the habitat was run from, just taken a day or two before the hurricane. This is what it looked like afterwards. And so I'm very proud. I was very proud of this. This is a piece of vinyl roofing, vinyl flooring that we put on the roof to stop the leaks so that we could stay there for a while. Now this was looking down from the deck that you saw in a couple slides before that, just before the hurricane. Turns out this was quite a collection point right at the back of this for boats that just kind of got pushed. So one of the reasons I'm showing you these pictures, besides the fact that it still remains as kind of an experience for me, I guess, is that I think it's showing you that obviously hurricanes are very strong, and they're particularly strong on the water. And one thing that I'd like you to keep in mind is that they're not just strong on the water, they're strong under the water as well. And they have a reach beneath the water, and they can pick things up off the seafloor. And so that's something that we'll get back to in just a second. All right, now I want to get back to the rocks around here and what's in them. So the rocks around, this is a geological time scale that the present day is at the top, and this is showing you the different eras, as they're called, and periods in the geological time scale. How many people in here have heard the term Jurassic? You know, like Jurassic Park, right? That's one that most people know. Well, Jurassic was a period in the era called the Mesozoic, but the Jurassic was far more recent in geological time than the period during which the rocks around Cincinnati were deposited, which was the Ordovician, which is during the Paleozoic era. And the reason we have these periods and eras in the designated in the geological record is because they're associated with big changes. And so you can imagine that when you go from one era to another, we can really observe very big changes in the geological record, and that's why those boundaries exist in the first place. So more to say about that in just a second. Turns out that the rocks around Cincinnati are really famous around the world among people who study the history of life because they're so abundantly fossiliferous. There's so many fossils in them that in North America, the upper part of the Ordovician is actually known as the Cincinnati. So that time interval is really called Cincinnati, which I think is kind of cool. This is a graph that's showing you, it's kind of a summary of the history of life in the oceans. Okay, so I mentioned a moment ago that we're not talking about dinosaurs now because they lived on land. We're talking about critters that lived in the oceans. And so in the geological time scale that you saw, the present day was at the top, and going back in the past was at the bottom. Here the present day is at the right, and going back to the past is over here. This is really sort of showing kind of a graph of life from the time that we first see a lot of animals in the history of life to the present day here. The Ordovician is right here, so the Cincinnatian is right about here as we work our way through time. And this is showing the number of, genus is just a fancy term it's a classification term, but just for want of a better way of putting it, it's the number of different kinds of marine animals that we see in the geological record. And I think when you look at this, one thing that you see is that it's not just that the rocks around here were fossiliferous, they were deposited at what turned out to be kind of a critical time in studying and understanding the history of life. There was a whopping big increase in the number of different species on the planet, and then there was a big decrease, which we call a mass extinction afterwards. So this is a really interesting time, and one of the things that attracts a lot of people, a lot of scientists, to look at these rocks, and just lots and lots of people, not just scientists, to collect the fossils because they're really very nice. Anyway, one of the points I wanted to make is that as we look through time, we see different portions of this, and reflecting different kinds of things. This is taking a different look at the graph that we just saw, and this is really trying to make the point that, without going into too much detail, because I don't have time to, that the point that I was making before, that the kinds of animals that we find in the fossil record around Cincinnati, which is, this is sort of the heyday of it right here, are going to be chock full of species of representing groups that are much less abundant today for the most part. Whereas today, we you see some different kinds of groups. So just take clams and snails. Most people know what clams and snails are, and they're very common. If you go to a beach today, you'll see a lot of them. We have some of them in Cincinnati as well, but if you look at this graph, it's showing the numbers of different kinds of clams and snails and other groups in the so-called modern fauna. There weren't as many of them in the Ordovician. Instead, you have these other things, and we'll take a look at some pictures so you can see what they were. You know, so this is actually a clam, but then there are some other things that have fancy names, but they're border names. So this is a trilobite. People know what a trilobite is? Have you seen it before? All right. So that's a trilobite. That's turns out that if you didn't know it, you'll know it now. Ohio has a state fossil. The state fossil is a trilobite, not that particular trilobite. This is probably the most common trilobite that we find in the rocks around here. And so it's an arthropod, which puts it in the same phylum and classification as like an insect, so it's, or a lobster, all in the same phylum. So anyway, I wish we had more time to talk about these, but you can see that these are really pretty spectacular, very nice things, and you can really just find these in the rocks around here. I wish we had more time to talk about them individually, but these are just some other fossils you'll find around here. Just to give you an idea, I included these pictures because these were taken just out in the field, you know, just when you're out there looking around, and you know, you'll just see fossils all over the place, and they're very easy to spot, and they're very eclectic. This one is especially cool because it's sort of it's a mass of something called a bryozoan, which it looks like a coral, but it's not really a coral. But what can happen through time around here is just the rain itself is acidic enough to dissolve some of the bedrock, and sometimes what that will do then is just leave behind these piles of fossils that you can kind of scoop up with your hand. And not just these guys, but also some of these other things as well. And so, but you'll also notice, and this is the next part of our story really, that they tend to be very highly concentrated in these layers, and that's the thing I wanted to mention. Okay, so we've talked about two things so far, and we have two more things to talk about, and I have 5 minutes to do it, so it's one of my flaws as a speaker. We talked about hurricanes, all right, and we talked about the kinds of fossils we expect to see in a rock that's Ordovician age, so somewhat different than what we see on a seafloor today. We also have to keep in mind that, and I mentioned before, that continents move around because of a process called plate tectonics. All right, and so this is what the world looks like now. Cincinnati is right about here. But we know from a variety of geological evidence and something called geomagnetism, among other things, that the continents were once in a rather different position. And in fact, we can start working our way back through time. So what I'm going to do is I'm just going to click through some slides that take us back in sort of like, 40 million, 50 million year chunks back to the Ordovician. So we're working our way backwards. This is the late Cretaceous. This is just before the dinosaurs became extinct. So this is sort of the time of the dinosaurs. So because now North America is here, Cincinnati was still on land, but there was a seaway going through what is now North America. There's another seaway here through what is now Europe. But you can see that it still looks vaguely familiar. Notice that the Atlantic Ocean was a lot narrower because the Atlantic is actually a relatively young ocean. It continues to open, actually. There's lots and lots of evidence of this. Working our way further back, though, we come to what it looked like at the end of the Paleozoic era, which is also the end of the Permian period, which is the last period. We had this, really what amounts to a supercontinent. You've heard the term Pangea before. It's the name of a store on Ludlow Avenue in Cincinnati. That's where the name comes from. So this has come to be known as Pangea, sort of when most of the continents kind of coalesced together kind of as one. Whereas now Cincinnati is here, so we're sort of in the middle of this large supercontinent, and this was before the Atlantic Ocean opened up. But if you go further back, Pangea itself formed from continents that collided together. So we go back in our time machine now to the Devonian period, which is in the middle of the Paleozoic, and you can see that what is now North America was here, what is now Cincinnati was on the border, and this other piece was over here. And then we'll go back to the Ordovician. All right, so here is Cincinnati there, okay? So a couple things to note. One is that as we surmise, because we have all these rocks called these fossils, and it was underwater, all right? And you can see that here. So was a big swath of North America. And so if you go to lots of places around North America at this time, you'll find Ordovician rocks that have fossils in them that are evidence of this, and various other places around the world. The other thing to note is where it is. It's, here today, Cincinnati is about 40 some odd degrees north latitude. Back then, it was in the South Tropics, inside about 20 degrees south latitude, all right? So here we have this very shallow sea, warm and shallow sea, sitting in the tropics. And so what do you think that means? It means hurricanes. So, and that's the point of this one. So just as a reminder, I'm putting this up on the this slide from before to show you when we're in the southern tropics, we expect them to bend to the left. This is a map that's not showing land and sea, it's just showing where continents are. This is for another study where Cincinnati was right about here. But the point is, it's in the southern tropics, shallow sea. So in the present day, when a hurricane hits the United States, as soon as it leaves the water and hits the land, it weakens, right? You know this, and so it starts to sort of rain itself out. Back in the Ordovician, if anything, when a hurricane came off the open ocean, it hit this big shallow sea, it would have strengthened. And so it's not, this is to say that if you, that slide that you saw that showed all those paths of hurricanes over a century and a half, take that and multiply it, by some factor to give you a sense that, I don't say it was a hurricane a week, in Cincinnati back in the Ordovician. But hurricanes were frequent, and chances are they were stronger than what we see today for the most part. Okay, and so you have to sort of keep that in mind then, and this is where the last part of the story comes in, and I have 2 minutes for it, so yay. So I mentioned before that hurricanes obviously they not only move boats around on the river, they were, and I promise you there were no boats as far as I know back in the Ordovician, and no people to make them. But there were critters living on the seafloor, and you see the fossils, and we've talked about that, all right? And so as those critters live and die, their shells kind of accumulated on the seafloor, just kind of sitting there, in addition to the living ones themselves. So a hurricane comes over, and it basically reaches down. The strength of the hurricane is such that it really disturbs the water, and if the water's not too deep, and the water around here was pretty shallow, it picks stuff up off the seafloor. All right, and so the stuff is all in suspension, being shaken around while the hurricane is passing over, and then the hurricane moves on. So when the hurricane moves on, all that stuff has to settle back out, and the way it does it is in a very characteristic way that we call a storm deposit. Okay, and so the way we see this around here is the main part. Again, without going into all the detail right now, is this part right here. You tend to get these very concentrated layers of shells. And you'll see these again and again in an outcrop. Sometimes in between them, you'll have what are called laminated units. They're kind of stripy because from the swash of the water, after the shells fall out of suspension, then the water's sort of doing this. And so as the sediments continue to settle down, you get this layer. In fact, this is the idealized version, but when you really get this depends upon a lot. It depends upon what kinds of sediments you have in the first place and how frequent the storms are. What we often see in the rocks around here is the storms are so frequent that we get, the fancy term is amalgamation. The term that I like better is cannibalization. The storms are so frequent that one storm will come along and partly cannibalize the deposit of a previous storm. And so you'll see that one cutting, and this is a little bit hard to see in here, but this is an example of this, where you're getting one hurricane deposit cutting down to a previous hurricane deposit. And you see this again and again and again in the rocks around Cincinnati. And so this is the reason you do it. It's because of the storms. The last point is that I mentioned sea level changes, so they're really, I'm going over by 1 minute, but I really am almost done. I mentioned that sea level goes up and down, and we see that reflected in the rocks around here. So if you drive around and you see road cuts, for example, on some of the interstates, I-275 is a good place, I-74 is another one where I've worked actually. up in the hill, if you're familiar with downtown Cincinnati, going over the Brent Spence Bridge and then climbing out into Kentucky, heading towards the airport, you can see them well, or various stream cuts that you might go. What you'll see is that sometimes you, and I might as well just go to it. This is actually an outcrop from, it's called the Breland Road Outcrop. I think it's exit 79 off by 275 in Kentucky, and Breland Mason Road. And so this is I-275, it's like back here. And then you kind of go down, and you can see this really nice section of rock. And if you really went close up, you'd see those individual layers that I was talking about. But you'll also notice, from more broadly away, the layers down here are rich in what we call a shale. They're kind of muddier. And then you see these things, these ledges sticking out. And those are coarser and richer in limestones. And this is a reflection of changing sea levels through time as well. They sort of cycle back and forth between those, and you can see several cycles of that reflected in the rocks over here. So that is it. That's all you need to know how the rocks around here basically got built in the first place. But to me, it's a really fascinating story. I keep moving away from the camera, so it's a really fascinating story of how a whole bunch of factors coalesce. I think we see the rocks. I think we do this a lot in life in general. We see something, we look at it, we just take for granted that it is that way. But I think it's fun to ask, well, how did it get that way in the first place? Why did it exist, in the form that it does? And I think that Cincinnati, the rocks of Cincinnati, tell a really interesting and compelling story that has so many different elements in it that, each of which contributes to the story of it all. So that's it.
Thank you.
So after that.